The question number 6 is the contact force exerted by the body on another body is equal to the normal force between the body. We can conclude that the first A is that surface must be frictionless. The force of friction between the bodies is 0. The magnitude of normal force equals that of friction. And D option says that body may be rough, but they have no tendency of relative motion. There is no relative motion between the bodies. But dear student, you know that whenever the contact force acts on the body, now in the form of the contact force, there is one component. One is the normal reaction and second is the force of friction, right? Now, if it's given that contact force is equal to normal reaction, that means the value of force of friction acting at that point should be 0. And let's look at the option. Uh, the force of friction between the body is 0. Yes, that could be the possibility. The magnitude of normal force equal to friction. No, it may be possible that body may be on rough, but there is no tendency. Yes. So the option to this one is B and D. And I write the answer to this question is 4. The question number 7 is an impulse I given to a body changes its velocity from v to 3v. The increase in its kinetic energy of body is given by these are 4 relations. Now the increase in kinetic energy of the body is final kinetic energy 1 by 2, let's say mass is m, and 3v square minus half of m into initial is v square. So that is equal to 8 by 2 m into v square, that is 4mv square. Now, what is given? Impulse given to the body, and impulse given to the body is equal to change in momentum, and the final momentum is 3mv, the initial momentum is m into v, so change in momentum is equal to 2mv. Now, we want the relation between I and v, so I can write kinetic energy like this one. 4mv square would be broken into two parts. One is 2mv and 2v, and this is nothing but here I. So this is I into 2v. So 2iv should be the answer, and the option second is 2iv. So question number 7 has the answer 2. Question number 8 is a particle of mass 2m moving with velocity 2v collides head on with another particle of mass m and with velocity v in the same direction. If the coefficient of restitution between the particles is 1 by 2, then loss in kinetic energy. Now dear students, this is inelastic collision and partially inelastic collision, and the formula for kinetic energy loss is 1 by 2 m1 m2 m1 plus m2 v1 minus v2 whole square, the initial velocity, into 1 minus e square. So we'll fill up the data. So one mass is equal to 2m, second mass is m, so divided by 2m plus m, and the velocity is 2v, same direction v whole square, into 1 minus coefficient of restitution is equal to this one. So 1 by 2, and this is equal to 2 by 3 into v square into 1 minus 1 by 4. So they become 3 by 4 and 2 cancel with 2 and multiply by is m. So this become equal to 1 by 4 m into v square. And look at the option, the fourth option is 1 by 4 mv square. So therefore, to answer to this question is 4. Question number 9 says, consider the following statements. The center of mass of two particle system divide the distance between them in the inverse ratio of their masses. And B statement, the center of the gravity of the body is the point through which the whole weight of the body acts. Now dear student, let's look at the option A. This is the first A statement. He says that this is a body with mass of m1 and this is the mass m2. Let's say this is the center of mass, and from here the distance is r1 and this distance is r2. Now the center of mass should be located at this location, so I write that m1r1 plus m2r2 should be equal to 0. And with respect to this, r1 is negative, so I write m1 into r1 is equal to m2 into r2. And look at this one, so m is inversely to the mass location is inversely to the distance. The center of mass of two particles divide the distance between them. So therefore the center of mass is dividing in the inverse ratio and C of their distance. So this statement is correct statement. And what would the second one? The center of gravity of body is through where the weight lies, and that statement is also true statement. So center of gravity through the where the total weight of the body is supposed to act. So both statements are correct, and therefore answer to this question is the third option. The question number 10 is among the following, for which body rolling along a level surface, the ratio of the translational energy to the total kinetic energy of the body is maximum. Now, dear student, when the body is rolling with mass m and velocity v, then the kinetic energy of such body will be equal to half of m into v square. And the total energy of such rolling body, total kinetic energy of this rolling body will be equal to half of m into v square plus half of I into omega square, and I fill mk square, and pair rolling omega is equal to v by r. So this become equal to 1 by 2 mv square 1 plus k square by r square. Now to find the ratio, the kinetic energy of translated to the total kinetic energy of the body, so this would be 1 by 2 mv square divided by 1 by 2 mv square 1 plus k square by r square. K is the radius of gyration, so 1 by k square by r square. Now to get the ratio, this would be the ratio will be maximum when this will be minimum. And you look at the body, the disk k square r square is 0.5. For ring it is 1, hollow sphere 2 by 3, and solid sphere it is 0.4. So least is for the solid sphere, therefore it will have the maximum the ratio, and the answer to this question is the 4 option.